Hello everyone. In this video we're going to be solving a system of equations. If you like this video, please comment, like and subscribe, and don't forget to hit the bell button for notifications. And let's get started. Now, so we do have a system of equations in three variables, and we have three equations. And equations seem pretty consistent with the sums being added to the products and giving us a numerical value every time. Now, first when I thought about this problem, I thought about giving you something like a parametric, like instead of putting the numbers 41, 26, and 125, I was going to use the given numbers or parameters like A, B, C, but then it would complicate things. So I wanted to keep it a little simpler than that. That's why I wanted to go with the numbers. But this is an interesting set of problems or set of equations because the solution method involves some nice trick that we use time to time. Okay, obviously, when you look at an equation like this, you might be thinking about, okay, can we add these two equations? Absolutely. Can we subtract these equations? Of course, we can multiply them, we can add them, we can do all sorts of things. Those are the techniques that we use with systems. But with this one, obviously, there's more than one way to solve it. For example, you can take the first and the second equation, in this case, right? And you can just go ahead and subtract them, because what that would do is it would eliminate the x, right? Which is kind of good. Well, not completely, but at least the x's would cancel out. So if you subtract them, you would be getting something like this. Y minus z plus xy minus xz, and then 41 minus 26 would be 15, right? Okay, cool. And then how could you proceed? Obviously, factoring by grouping, y minus z times 1, and then this would be x times y minus c. So obviously, there's a way to factor this expression because y minus c is a common factor, so I can pull that out, and then the other factor is going to be x plus 1. I just want to write it in standard form. Okay, cool. So the first two equations gives me something like this. And then I can do the same thing with the second and third, and so on and so forth. Would this lead us anywhere? I mean, it should, right? I haven't tried it, but it looks like it's going to get you somewhere. Okay, so that's one way to approach it. Well, if we add all these equations up, we would be getting the x 2 times, the y 2 times, the z 2 times, and then we would get xy, xz, and yz. What are we going to do with those? So there are different approaches, obviously, and you can try all those things. But in order not to keep this video too long, I want to keep it kind of short, I'm going to use one strategy, but I already talked about, different strategies. Hopefully that'll give you some ideas. Okay, cool. So what are we going to do? To be able to solve this system, we're going to use something called Simon's favorite factoring trick. It's also known as SFFT, but a lot of times it's too long to say like Simon's favorite factoring trick. I'll just call that Simon. Okay, cool. So we're going to use Simon for this system. How do you use Simon? Well, the Simon basically involves making this expression factorable by grouping, by adding an appropriate term. And there are many different variations of Simon, obviously. You can make it a little harder by adding some coefficients. Let's say instead of x plus y, if I had 6x plus 5y, that would be a different story. And I'll also show you some examples later on, maybe in another video. We'll do a problem with a different type of Simon. Okay, anyways, so let's go ahead and use Simon here to solve this system of equations. Now, Simon requires that we handle each equation separately. So again, solving systems of equations, there are many strategies, and one of them is adding all the equations up or multiplying one equation by something and then adding it to the other one or subtracting. There's so many ways to go about it. But with Simon, we're going to look at each equation individually. And this is how, without further ado, let me show you what that means. Okay, cool. So this is what we're going to start doing. And I can't decide on the color here. So I'm going to take the first equation and add 1. And actually, when I'm writing this, I'd like to have the product first. I'm by convention. Why? Because it makes factoring a little easier. So I just prefer to write it that way. And to this equation, I'm gonna add 1. And you're gonna know why. You might be saying, like, out of the blue, you're just adding 1 to the equation. Well, there's a reason for it, which I'll show you now. Now, when you add 1 to this equation, you make it factorable. How? Well, if you look at the first two terms, you get x times the quantity y plus 1. And then you get 1 times y plus 1. Isn't that nice? Cool. I mean, that was a simple trick, right? I mean, it's easy to use, but it's powerful. So now I did get something factorable because y plus 1 is a common factor. That's how Simon works. That's how grouping works, you know. So now this becomes x plus 1, writing the alphabetical order, you know. Y plus 1, the product is equal to 42. Now what's so cool about this technique, like you make a big deal about it, right? Like you add 1 to both sides, Simon, you give it a special name, so on and so forth. Okay, so the big deal is that this makes the system easily solvable. Why? Because if you consider the same technique on all these equations, for example, I don't have to go through the same steps, right? I can just show you what it looks like. For example, if I do the same thing for the second equation, by the way, I'm numbering these equations 1, 2, and 3. So that's when I say second equation, that's what I'm referring to. Okay? So in the second equation, if I add 1 to both sides, I should be getting xz plus z plus 1. And again, I can take out an x, and it's going to be x plus 1 times z plus 1. But I have to add 1 to both sides. Therefore, you should have 27 on the right-hand side. Don't forget that. Otherwise, you're going to be in big trouble. Okay, so to keep a long story short, you're going to get x plus 1 multiplied by z plus 1 is equal to 27 from the second equation. All right, awesome. That's cool. Now, you may still think about this like, what is so good about it, right? Let's do one more with the third equation, and hopefully it'll make more sense to you at this point. Now, I have y plus yz, again, adding 1 to both sides, writing the yz first, yz plus y plus z plus 1. Okay, that's going to give you what? Y plus 1, that's going to give you y plus 1 multiplied by z plus 1. Again, don't forget to add 1 to both sides. It should give you 126. Beautiful. Now, what is so beautiful about this? Well, if you look at this expression, now we have products and we see the same thing repeating. X plus 1 occurs twice, y plus 1 appears twice, and z plus 1 appears twice. So, what is that supposed to mean? Well, that's supposed to mean that if you take these equations and multiply together after the first manipulation step, then you should be getting something nice. Why? Because you're going to get x plus 1 squared, y plus 1 squared, and z plus 1 squared. On the right-hand side, you're not going to get something nice, but what I'd like to do is, I'd like to factor these expressions. I'm going to show you how. For example, 42 can be written as 6 times 7, which is 2 times 3 times 7. Okay. 27 can be written as 3 to the third power, and 126 is 2 times 63, which is 2 times 7 times 9, and as you know, 9 can be written as 3 squared. Okay, cool. So now I did the prime factorization pretty much, and the reason why I did that is because I'm going to square root this expression. That's going to be my next step. Oh, I forgot to say x, y, z are all positive numbers here. Well, let's suppose they're not positive. We're going to find both solutions. You know, it's no big deal. Now, but let's go ahead and simplify this expression. So can I safely say that, okay, this expression can be written as x plus 1, y plus 1, z plus 1, all together squared, and the right-hand side is going to equal 2 to the second power, and then 3 to the sixth power, and 7 to the second power. Awesome. Now, notice that the right-hand side is a perfect square, and the left-hand side is a perfect square, and we can take the square root of both sides. When we take square roots, we're going to get two values. That's okay. We can handle both. Cool. Now I'm going to go with the positive version first. So if I square root both sides and go with the positive solutions, then I should be getting something like this, right? X plus 1, y plus 1, and z plus 1 all together multiplied is going to be the square root of this expression, which is 2 times 3 cubed times 7. Or you can call that whatever you want. Doesn't really matter. No big deal. But now what we're going to do is, from here, we want to find the values of x, y, z, right? So how do you find that? Well, if you go back to the modified equations here, you notice that we have the two-way products, and this is the three-way product. So if I take this, again, a smart method to use here is divide this equation, this one, by this one. Let's call this equation number 4. Let's call this number 5. Let's call this number 6. And let's call this number 7. How about that? Let's number all the equations so we can refer to them by numbers. So what I'm trying to say here is, if you divide equation number 7 by equation number 6, what happens is everything cancels out except for x plus 1. So you get the value of x from there. So let's go ahead and do that. I'm going to divide x plus 1 y plus 1 and z plus 1 by y plus 1 times z plus 1. And this should give me x plus 1, right? Because everything is going to cancel out except for x plus 1. Well, what are the values? Well, the values for the top is going to be 2 times 3 cubed times 7. And for the bottom, if you look at it, 126 was 2 times 63. Remember, we wrote it as 2 times 3 squared times 7. 2 times 3 squared times 7. Awesome. Isn't that beautiful? We are able to prime factorize this, whatever. Anyway, so these two cancel out, and you end up with a 3 only, right? So that means x plus 1 equals 3, which means x equals 2. So that's our first solution for x. Cool. And if you do the same thing, take number 7, and divide it by the number 5, which is 27, then you should be getting the value of 5. Let's go ahead and do it. So you take this one. Okay, I can keep this long story a little shorter. So what I'm trying to say is basically, if you take the third one, which is this, which is this one, right? Number 7. And if you divide it by number 5, which is 27, right? 27, which is 3 cubed, then this should give you the value of y plus 1. That's what I'm trying to say. The 3 cubed cancels out. From here, you get y plus 1 is equal to 14, which means y is equal to 13, right? So that's the y value. Okay, how do you find the z value? You take the x plus 1, y plus 1, and z plus 1, and divide it by the equation number 4, which is 42, which can be written as 2 times 3 times 7, right? As 6 times 7, and you get the value of z plus 1, because that's the only equation that doesn't contain z, right? So this should equal z plus 1. And from here, the 2 and the 7 cancels out, leaving us with 3 squared, which is 9. And from here, we get z equals 8. All right? Awesome. So those are the x, y, z values. And that's going to give us our first ordered triple, which is 2, 13, and 8. Let's write it down here. 2, 13, and 8. Now, similarly, if you consider the negative square root of the expression that we just found, right? Then this product, instead of equation number 7, you're going to get with equation number, you're going to obtain equation number 8, which can be written as the negative of 2, 3 to the third, and 7, right? This one. And if you go ahead and divide this equation by everything, like pretty much repeat everything you've done here. For example, first we divided by this number, we get 3. But notice that that equation, that is not going to change. The bottom is not going to change. The only thing that changes is the top. So it's just going to negate everything, right? So in other words, if I negate everything, that's going to be another solution. Therefore, from here, we should be getting just another order triple, which can be written as -2, -13, and -8. That's just going to be another solution. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed the video. I'll see you tomorrow with another video. Is that a geometry puzzle? Take care. See you tomorrow. Bye-bye.